Hi, I'm Nick Smith from the Sustainable Nutrition Initiative, introducing the new cropland feature of the Delta model. So to calculate the land area required to produce the plant foods in a Delta model scenario, we've used FAO data on annual national crop production and area harvested. Using this food balance sheet data, we can calculate the amount of a crop that's used for human food, for animal feed, or for non-food uses like biofuel production. This can be done for all the plant foods in Delta and then totaled for each plant food group, as shown here. Note that grazing and rangeland are not currently included because we don't have sufficient data to do so. But not all land yields the same amount of a crop each year. So any decreases or increases in production might occur on high-yielding land or on low-yielding land. To capture this uncertainty, we've analyzed the national yields in tons of crop harvested per hectare of individual crops from around the world. As an example, let's consider almond production, because the yield of almonds per hectare varies greatly in different parts of the world. So here we can see that the global production of almonds in 2018 was around 3.2 million tons, and the land area used to produce it was around 2 million hectares. This is an average yield of 1.5 tons per hectare. The best yielding half of production used 370,000 hectares, or 18% of the total land producing almonds, to produce 1.6 million tons of almonds. So this is a yield of 4.3 tons per hectare. The worst yielding half of production used 1.7 million hectares to produce the same amount of almonds. So that's a yield of 0.9 tons per hectare. So if we consider an increase in the production of almonds, we can use these values to think about the land requirement of this increase. Delta calculates the increase needed at the average yield, at the best half yield, and the worst half yield. The same approach can be taken for reductions in production. So the land no longer being used could be average yielding land, could be low yielding land, or it could be high yielding land. So Delta calculates the land requirement under each of these assumptions to give the user a range of requirements. These ranges are calculated for all crops, and the aggregated ranges are displayed as error bars on the cropland use plots as shown here, whenever the user increases or decreases crop production. The cropland model also allows the user to change the efficiency of production. This is done by increasing the performance of the worst yielding half of production. The yield here means the tons of crop produced per hectare, so can be thought of as the performance of the land. Moving the slider increases the percentage of the worst yielding half of production that's improved to the performance of the best yielding half. This results in the same amount of production, but with a lower land footprint, an efficiency gain. Moving the slider to 100% brings all of the worst yielding half of production up to the efficiency of the best half. And these charts for each crop in the model can be viewed interactively under the Helpful tab.